Hello, students. Had a question out of 4.2. Question was about problem 9. So this is 4.2a, and the problems are very, very similar. So I'm going to give you the idea so that you have a few to also practice on. Let's see if we've got this down. Actually, I guess you could practice on these, and then I'll do the other ones. It's the same difference. Practice on one, do the other. Okay, so here we go. We got these. So if I do these for you, then I want you to go and try part A, practice, make sure you understand it, and then you can kind of check yourself. So let's jump in here. Let me get a little bit of white space. Again, we're talking about question number 9. So we did part of this, I think, in class where we kind of did the factorization. So same kind of thing. I think the big piece to understand here is we want prime factorization. So when you look at, let's say, question B, look and say, is this in prime factorization? And it's not, right? So you take a look and say, well, what would make this prime factorization? Well, you see the number 8. So break the number 8 down into prime factorization. 2 times 2 times 2. Now, like we said in class, you could rewrite that. So that would be the same as 2 cubed. And let's see if I can move that so it actually looks like a cubed. There we go. So that's 2 cubed. Now the big piece though is, even though that is 2 cubed, what we really have is we have 2 cubed. Oops, I don't know how I got on the line tool. Sorry about that. Give me a second. There we go. Okay, so we have 2 cubed, but it's really 2 cubed to the 4th power because it says 8 to the 4th power. So it's this whole thing to the 4th power. Okay. So now what I really have is I have 2 cubed to the 4th power. So now we got to go back to our exponent rules. And the exponent rules say, well, what does it mean? Raising something to the 4th power means kind of multiply it by itself 4 times. So you'd have 2 to the 3rd, 2 to the 3rd, 2 to the 3rd, 2 to the 3rd. And remember, when we have the same base, we just add the exponent. So that would be 3 plus 3 plus 3 plus 3 if you wanted to write it out. But kind of the quicker way is to realize, hey, that's the same thing as 2 to the 12th power. And that was one of the properties from the last unit about multiplication. So now I have 2 to the 12th. I used to have 8 to the 4th. Now I have 2 to the 12th. Okay. Oops. Let's see here. Grab my eraser. Okay, that takes care of that portion. Now I also have 32 to the 5th power, but we're going to do the same thing. What is 32? We'll break it down, right? It's 8 times 4. Right, that's 32. 32 is 8 times 4. Okay. But can we break that down any further? So 8 times 4, well, that would equal, what is 8? Well, we just saw 8 was 2 times 2 times 2. We saw that. And then we multiply by 4, and 4 is 2 times 2. So really 32 is 2 times 2 times 2 times 2 times 2. So 5 of those, which again, we could kind of look and say, well, wait a minute, I could shorten that down because that would be the same as 2 to the 5th power. And let's grab that 5 and kind of bring it over here because my little pen is not functioning at this moment. So I have 2 to the 5th power. So 2 to the 5th power, that's 32. Now notice though, right, I have that whole thing raised to the 5th power. So 2 to the 5th is just 32. So I have another 5th power here that I would want to bring up there. So I have 2 to the 5th to the 5th. Okay, and we'll do the same property of exponents, and we'll just kind of simplify this and say, oh, that's the same thing as 2 raised to the 25th power. And there we are. So now I have 8 to the 4th, which turns out to be the same thing as 2 to the 12th. And I have 32 to the 5th, which turns out to be the same thing as 2 raised to the 25th power. And now all I want to do is bring those together. And so if you're kind of looking at it and saying, well, wait a minute, I have the same base for each. They both have a 2. One of them's to the 12th, one of them's to the 25th. So I could bring those together, and my final answer would be 2 raised to the, well, it's just like, think of how many 2s you'd have in a row. If you wrote 12 of them down, then you wrote another 25 of them down, you'd end up with a grand total of 37. And that would be your prime factorization, is 2 to the 37th power. So remember, for primes, you want it to break all the way down. You want to be all the way down to prime numbers. All right, let's take a look. We'll do the next one. I don't know, part C. Part A is pretty similar. So you just have 16, break it down. 4 times 4, break it down. 2 to the 4th. 81, break it down. 9 times 9, break those down. Each 9 is 3 times 3. We're going to primes. We're not just factoring. Break it down to primes so that we can see. Okay, find the prime factorization of part C. So again, now here I have 2 squared, 3 to the 5th, and 7 to the 55th. And this is where I'm trying to see, what do I have in common? Because in the middle of this problem, like smack dab in the middle of this problem, they went and put this. Somebody went and put an addition sign. So remember, addition does not match up with the term factorization. Factorization means multiply. So we need to turn this into multiplication. And we can do that using the distributive property. Now we're going to use it in reverse, which means we're going to be factoring or turning this problem into multiplication. Okay, I mentioned one in class today. If I had 3x plus 6y, something along those lines. If you think about it right now, this is an addition problem, but you could turn this into factorization by factoring out a 3, and the distributive property says you'd end up with x plus 2y. So notice what I've done is I've turned an addition problem, right? So the first step I would do over here is I'd multiply each piece, and then I'd add the results together. I have turned that into a multiplication problem. 3 times this other quantity. Okay. So that's what I'm looking to do here. Now let me get rid of my arrows. So what I want to do is write out anything that I see that is common. So usually when you have primes like this, I notice there's a 2 in each term. Now the question then is, how many 2's are there that I could kind of factor out? So the first term has 2 2's. Okay, that's great. The second one has 4 2's. Well, that's more of them. But remember, I have to be able to pull it out of each term. So the most that I could get out of each term is 2. So what I would do is I could write this down as being pulling out 2 squared. Okay, and I'll move that over just a little bit so it looks a little bit nicer. So I have 2 squared. Okay, that's what's pulled out. Now oh, and by the way, there's more coming down the road here. There's gonna be a little bit more we have to put in here, and then we're gonna have parentheses and a whole bunch of stuff that we're gonna be able to write inside of parentheses, because we're going to use the distributive property. So I have 2 squared. Okay, perfect. That takes care of the 2's. Let's go on to the 3's. So now bring your gaze over and look at the 3's. Okay. So the first term has 5 3's, 3 times 3 times 3 times 3, 5 times. The second term has 4 3's, 3 times 3 times 3 times 3. And so what you end up with is what? The most that you could take out is 4. Now, I'd love to take 5 out, but the second term just doesn't have enough 3's to make that happen. So I need to take out 3. And how many times? I'm going to take it out 4 times. So I bring out a 3 to the 4th. Okay. And lastly, let's jump on over to the 7's. Let's see. The first term has 7 to the 55. The second term has 7 to the 55. So the most I could take out would be 7 to the 55. So there's 7, and here's the 55. Okay, there we go. All right, so now what we're doing is we've figured out the biggest thing I can factor out. That is fantastic. Now all I have to do is come back and say, well, let's go in there and see what remains. So go one step at a time. if I pull out a 2 squared out of the first term, we can see that 2 squared right here, there's no 2's remaining. So that looks pretty good. So don't put anything in the front for the 2's. If you want to think of it, you could think of a 1 that's there. Next up is the 3 to the 5th. I'm taking out 3 to the 4th power, which means there is a 3 that remains. So I'm going to put that in the parentheses. There's definitely a 3. You can picture, if you need to, write that as 3 to the 1st power. That's totally fine. And lastly, 7 to the 55, but I pulled out all 7 to the 55. So that looks like we're in good shape. Then I can put my plus sign. Oops. Make sure I make it a plus sign, not an equal sign. And then I go to the second term. Now the second term says 2 to the 4th, but I pulled out 2 squared. So that's going to leave me with 2 squared remaining. Next up is 3 to the 4th, but I pulled out 3 to the 4th, so nothing else there. And 7 to the 55, but I pulled out 7 to the 55, so again, nothing else there. So again, so I have 2 squared, 3 to the 4th, 7 to the 55. If you distribute this to each piece, the first term is going to look very similar to this, but it's going to have one more 3, and that matches. The second term, when I multiply over here, is going to have 2 more 2's, but everything else will be the same, and that matches as well. So the next step here, what is this going to be? This is going to be 3 plus 2 squared is 4. And 3 plus 4 is 7. So my final result, so this is a 7. So this entire quantity that I was looking at here becomes a 7. Now notice it's multiplied because I turned it into multiplication. I factored it. So when I think about having one additional 7, my final answer would be equal to 2 squared. I'll write it in the old school way with the little caret representing the exponent. 3 to the 4th. And now it would have been 55 sevens, but I have one more of them. So I'm going to have 7 to the 56. Okay. Again, if you really want this in the other notation, it's just the way my computer is right now. It's not going great. 3 squared times 2 squared, and then I have 3 to the 4th power. Okay, perfect. Times, and then 7 to the 56 power. And that would be my prime factorization, broke it down into primes. All right. There we go. So that takes care of those. Questions were on that type. Again, if you see something where you can't factor, like part D looks a little bit more challenging because, again, there's nothing I can really factor out of that one. There's nothing in common here. I have 2 times 3 times 5 times 7 times 13, and then a plus 1, which is like, okay, great. But all you have to do then is, in this case, actually, you need to multiply all these numbers together and then add the 1. And if you do multiply all those together and add 1, you'll get a new number. And then you need to break that into its prime factorization. We cannot sit and have a plus sign because plus signs are not factors. They're addends. All right. Well, that wraps it up for me. Let's see here. What's going on? I must not have hit the right camera button. Did I? Whoa, there we are. All right. So that wraps it up for me. If you have other questions, please let me know. Otherwise, have a great night. All right, off you go.